want to thank everybody for taking some time out of your busy schedule to come listen to Tony and I speak. My name is Mitch Matheny. I'm with EWI, and today I'm going to be talking to you about some really exciting advancements that we've made in the world of ultrasonic package sealing and how that affects everyone here in this room. So before I get too much further, I'd like my colleague Tony to introduce himself.
Hello everybody, Tony Noser. I know many of you. My background has been in food packaging, so I've met many of you through the years. I think you're going to find this presentation very interesting and informative. Thank you.
Thank you, Tony. So one other thing I want to get out of the way before we get started is a quick definition of ultrasonics for those of you who may not know what it is. So when we talk about ultrasonic package sealing, we're talking about high power ultrasonics, which is the application of intense acoustic energy to change a material or a process. In this case, what we're doing is we're using ultrasonic vibrations to move two layers of film together. So there's movement, there's friction, there's heat generated, very locally creating enough heat to melt the polymers that we're trying to join. Turn off the ultrasonic energy, those polymers re-solidify, and we've now welded or sealed those two polymer film structures together. So what does that mean for all of you guys that are here today? Well, there's broad implications across the entire packaging industry or value chain out there. So if you're a resin guy or a film converter, you've got new material opportunities here. So there are some tough films out there, there are some films out there that may be tough to seal with conventional thermal sealing techniques. A good example would be a PLA, where ultrasonics can easily seal through PLA film structures. If you are an equipment integrator or an equipment supplier, your opportunity is new ultrasonic offerings. And one thing that almost every ultrasonic system has out there is the ability to monitor the amount of energy that you're putting into every seal. So imagine the quality control on the shop floor when I now have a process that I can monitor one of the primary inputs into the process to know whether I've got a good seal or not. If you're a CPG, big opportunities for you are going to be the film savings, because we can create incredibly strong seals in much smaller areas. So instead of those big 12 millimeter wide seals, we're talking seals down to 1 millimeter wide. You're also going to notice nice improvements in your coat date, because those seals are going to be much more hermetic or leak tight seals. Now if you're a consumer, you're simply going to get fresher product and better looking packaging. So in the next 20 minutes, you're going to hear me talk about some demonstration data, because we've delivered about 5 million packages to market. You're going to hear about the quality data that goes along with that, and you're going to hear about some of the cost savings data. We want to focus on that because we realize there are others here doing ultrasonic package sealing. We realize over the last 10 or maybe even 20 years, you've heard a lot about ultrasonic package sealing but haven't seen it implemented properly, and we want to show you how to do it. When we first started taking a look at this opportunity, there were a lot of things that we noticed. But one of particular interest was the amount of packaging that went to the seal region, somewhere around 10%. Now that in and of itself is okay, that's not that big of a deal if those seals are working hard for us, but they're really not, they're leaking. And ultrasonics can solve that problem. It can stop those seals from leaking and at the same time save you material. Now before, again, going back to we've heard this before, I've tried ultrasonics and it hasn't worked for me. I want to make you an offer before we get too much further, is come visit EWI. Give us some film samples. We'll seal it on our equipment and let you evaluate it for yourself. So Tony, why don't you tell us a little bit more about leak rate?
Thank you, Mitch. That's a great offer. There's an opportunity to demonstrate this curve with your own materials. What we find is when you go into the market with a chip bag, whether it's a corn chip or a potato chip, but particularly something that you gas flush, you're noticing dramatic performance differences based on the leaker rate of the bag. The leaker rate of the bag is very dependent on it tucks and pleats. It's very dependent on the materials that you choose, bag maker type. A huge number of factors do that. But when you look at average bags in the market, just go in the market, buy a bag, test the headspace oxygen, you're finding a curve that looks like this one. It may vary a little bit, but as Mitch said, if you believe you're not getting leaks, let's go look. What I would bet is when you go and you test in-market bags versus what's possible on an ultrasonic device, you're going to see dramatic differences in headspace retention, which is going to directly relate to the shelf life of the product. I've made a few chip bags in my day. I understand this. I can't name the company. Go look on LinkedIn, you'll find it. If you've had a bag of potato chips though, trust me, you know the company. So essentially, we can show significant improvement after just a short period of time. If you're in a long code situation, the advantages are dramatic. So you're spending a lot of money today on barrier packaging. If the bags leak, you're not getting all the value out of it. Let us help you make bags that don't leak. Mitch?
Thanks, Tony. So as we're developing this technology, one of the early benefits that we saw was the material reduction, taking seals that are typically a ½ inch wide clear down to as small as 1 millimeter if you want to. But as we're developing and bringing this out there, we knew we had to do a lot more than just say, hey, look, we made a few bags sealed, we saved you some material. We knew that we needed to demonstrate that in a hardened mass production environment across millions of packages, and we've done that. Beyond that, we knew that we needed to run a range of materials. We've done that as well. And we also needed to bring it to market in a way that makes good economical sense, and we believe that we've done that as well. Now I'm going to turn it over to Tony, and he's going to give you a little bit more detail in each one of these areas.
Thank you, Mitch. So when we looked at this, you've got an opportunity then to say, let's look at the seal integrity. The first thing that you can see is you're getting a seal strength that's very comparable both for heat seal and ultrasonic sealing. That was by design. So we didn't want to make bags that the consumers suddenly couldn't open. You defeat the easy open performance features of many of the bags. So a key feature is similarity. What you're looking at though is the ultrasonic seal would be much smaller. Now you can have a single feature 1 millimeter seal, or you can do multiple feature 1 millimeter seals. So 2 1 millimeter seals, 3 1 millimeter seals, if you wanted to give a bag that had a similar appearance in terms of seal width, but you'd have basically much better seal integrity because you're potentially making 3 distinct seals. So what you found is on a tortilla chip bag, this would be kind of a workhorse technology where over a broad range of materials, you can get very high seal strengths, very high integrity. It works very well on thick films that you might see in a pretzel bag. Obviously for materials like a potato chip bag where you're gas flushing, significant advantages is there as well. And sorry for some of the petroleum guys in the market, this works extraordinarily well on materials like PLA that don't conventionally heat seal, and you can simply use a PLA-based bag. So what we were able to do is demonstrate with retrofit kits that are applied to your bag maker. We're agnostic on who is making the ultrasonics, the ultrasonic generators, things like that. We certainly have some people we point you towards though. We're agnostic to the equipment type. So regardless of whether it's a reciprocating bag maker that's 30 years old or a new one, we can work with that as well. We're deploying it as retrofit kits. It can also be deployed as OEM with a single sonotrode, and this is a key point. We're making bags that are as wide as 12 inches. You're seeing wide bags out there. Many of them are using multiple sonotrodes. That's another key advantage of this technology. Finally, overproducing 5 million bags, you didn't see consumer complaints. They weren't complaining about bag tears. They weren't complaining about stale products. They weren't complaining about open bags in the marketplace. The technology works. It's very sound. It's very reproducible. So let's talk a little bit about what the opportunity is from the standpoint of an end user, because it's going to be about, is there income in this, is there savings in this to justify the investment? When you look at a relatively small bag, this is about the size of a common vend bag, something that falls out of a vending machine. You've got some certain seal strengths and some certain seal sizes and the width of the bag. What you're finding with some fairly basic assumptions, you would have a bag that basically comes out and is about 10% smaller. When we looked at this and you do the math on this, you're looking at a film savings of about 10% on a bag maker that's running at a reasonable speed. Okay, it's not 500 bags a minute, it's about 90 to 100 bags a minute. You start looking at potential savings per bag maker of $100,000 a year in film based on this film price and a 10% smaller bag. It's a very significant opportunity. You've got payback periods in the frame of 1 year. So you're easily being able to, on a retrofit kit with smaller bags, not to mention the distribution savings of smaller bags, the quality advantages of smaller bags, you're getting significant productivity advantages that can pay for retrofits in under 1 year. Back to you, Mitch.
Thank you, Tony. So, the things that Tony just talked about, I realize that those are some pretty big claims, and I also realize that many of you in this room probably have no idea who EWI is, because we don't have a big presence in the packaging industry, or why you should consider partnering with us. So a little bit about EWI. We're a research and development company. We've been doing this for about 30 years. We specialize in materials joining. We have the most extensive, comprehensive set of resources in materials joining in North America. We're not here to sell you a piece of equipment. EWI is here to develop the best possible sealing solution for your application and let you work with your preferred suppliers to put that on your shop floor. And that's exactly what we do, is work with companies like yours to bridge the gap between R&D and the shop floor. Okay, so we've applied our ultrasonic packaging technology so far to 2 different platforms. One of those is reciprocal vertical form fill seal bag makers, and the other is rotary vertical form fill seal bag makers. But I want you to think much broader than that. This technology can be applied to pouch machines, horizontal flow wrappers, large format packaging. The possibilities really are endless. This is just the first 2 applications that we've worked on. So if I may, I will play you a quick video. Okay, there we go. So what you're seeing here is the unit that we delivered over 5 million packages to the market in. It's a single sonotrode system on a reciprocal bag maker, single sonotrode about 13 inches wide with a single transducer working in a reciprocal motion to make those ultrasonic seals up to 12 bags up to 12 inches wide. And we did that across potato chip packaging, tortilla chip packaging, and pretzel packaging. Again, as Tony mentioned, all with no customer complaints. Saw a lot of really nice advantages using that. And as you go around the show today, you're going to see a lot of other vendors that have their ultrasonic solutions. I would ask, have they done this in an environment where they've delivered 5 million packages to the market? Do they have a scientific understanding of ultrasonics and how it works so that it can be implemented properly to do that? But I do realize at the end of the day that you've seen this before. Something that I guarantee that you've never seen before and that is truly revolutionary is our rotary solution. I'll start the video here. So you may have seen some rotary ultrasonic solutions out there before. I'm going to point out the things that we're seeing here on this video. You see a single rotary sonotrode in the middle of the screen, and what you can't see off to the left or right of the screen is a single transducer. These things are all symmetric and mounted along the axis of rotation. Okay, we don't have a clunky bar horn with a bunch of transducers and another one down here running over top of themselves. Everything's mounted along the axis of rotation, free to spin around. Significant cost savings and complexity savings here. So we believe this opens up the possibility now to be able to do reciprocal, rotary, big bags, small bags, a lot of different film types. If you've got a large fleet of bag makers out there or equipment, and maybe before you could only do some of these machines or some of these machines over here, we've got an offering that allows you to update your entire fleet of bag makers or your entire fleet of equipment. Okay, so a lot of those advantages that I was talking about on our rotary ultrasonic stack were maybe hard to grasp from the video I was just showing. So now I've got a nice illustration up here to walk us through it a little bit slower. So again, single sonotrode. We have 2 welding faces, one on this side, one on this side, that are both vibrating to give us our ultrasonic energy we need for the seal. We come back to a transducer that is mounted at 90 degrees to the sealing faces. You'll find that that's something that is not done in the world of ultrasonics. Everything about this is a very novel approach. And the U.S. Patent Office agrees with us on that. We were issued a patent about a year or so ago. So So how does this work? Well, really the best place to start is by looking at a traditional ultrasonic stack. So the ultrasonic stack on your left, that's what you're going to find in a reciprocal bag maker application. That's the most traditional use of ultrasonics out there, okay? We can do reciprocal ultrasonic joining with one transducer and one horn. So we said, why can't we do that with our rotary solution? So through some pretty novel design features, which we can't get into here, but I encourage you to go out and do some research on the patent and find out more about that, we've done a single sonotrope, a single transducer mounted 90 degrees to the sealing face. We can have our input ultrasonic wave or ultrasonic energy translate that 90 degrees to the sealing faces. So now we believe we truly have an economical offering that you can go out there and apply this to your rotary systems. Again, this is bigger than just rotary vertical form fill seal bag makers, going back to horizontal flow wrappers or many of the applications that I may not even be aware of, and maybe this gets the wheels turning as you're thinking about it. So where do we go from here? We've got this great technology. We're trying to get it out there in industry. Again, EWI, we are not the ones making the equipment or selling the equipment to you. That's not our gig. We develop this technology. We want you to work with the engineering organizations that you're comfortable, that you already work with. Maybe that's your OEM supplier. Maybe that's an integration supplier who can retrofit your equipment that's out there. So how do you get started with this? It's really quite simple. Come talk to myself, Mitch Matheny, my colleague Tony, Dale if you'd stand up, and Lou if you'd stand up as well. So Dale's another EWI employee that will be down in our booth along with many other fine folks. You can stop by booth E7159 anytime to find out some more information. If you're interested in doing a reciprocal retrofit, Lou is our partner over at Laco Tool that can talk you through a little bit more about how that might look and work. Now, our preferred method right now of doing this is through a consortium. So we're going to be forming a consortium with CPGs, equipment suppliers, ultrasonic equipment suppliers, and that's how we want to push this forward. So a quick recap of some of the advantages we've just talked about. Quality implications, code date extension, film savings, the direct money associated with that, distribution advantages, and shelf clearance gains. A couple other very specific savings to look at. Tony talked about the material savings and how that can correlate over to specific dollar savings. 11% film savings, translating back to 90 to 100, well over $100,000 in savings, depending on what kind of film and how fast you're running, as well as a lot of opportunity and reduced distribution costs and shelf space. So we've presented here a technology that's very broad-reaching, and we believe it touches virtually everyone here on this value chain. We believe we've given you an offering that can allow you to change your business in something quite significant. At this point, we'd like to open up the floor to Q&A.